So, hello. I'm Davide Vercelli. I'm a PhD student at Percro Laboratories at Sant'Anna University, which is a university based in Pisa, Italy. And I'll talk about this emerging toolchain for virtual reality and web applications involving XVR, which is a tool we have developed at our laboratories, and Blender. So in this talk, I will introduce XVR to you, and then I will also introduce Blender. No, I'm just kidding. And I hope you all have a basic understanding about Blender. And I will talk about how Blender and XVR can cooperate. This cooperation right now is in its early stages, and it's mostly a work of mine. But I hope it has some future. So we'll talk about current uses and possible future directions. The objectives of my talk are to raise interest in both tools. So today I hope to raise your interest in XVR, and in other occasions I talk about Blender to XVR users. And this will not be the case today, of course. In order to foster further development and to so that I can justify my time spent on Blender at work. And I would also like to get some ideas and feedback, if you have some, about this work. So just two words about who are we, Percro Laboratories. We work with 3D and haptics, more in general virtual reality. So for those of you who don't know what haptic interfaces are, I will attempt a brief explanation. So the point of virtual reality is to deceive all your senses in order to make you believe that you are in an entirely different place. And when we talk about virtual reality, we often think just about deceiving the sense of view, but it's also important to deceive touch. So haptic interfaces are just this, to deceive touch with gloves and with every sort of force feedback devices, such as exoskeletons. You can see the first image up there. So about XVR. XVR is an integrated development environment. This is a screenshot about it, open. And it features also a custom scripting language, which is quite easy. It's JavaScript-like, and it generates compact, precompiled bytecode. With a very fast compiler. And you run XVR applications through a virtual machine, which has been designed with really compactness in mind, so it's really embeddable and really lightweight. What can I do with XVR? Well, all sorts of things, or at least we really use it for all sorts of things. 3D web applications is probably what could interest you most, but also stereoscopic applications. It's really easy to convert an XVR monoscopic application into a stereoscopic one. And with different kind of stereoscopy, active, passive, anaglyphs, virtual reality applications, more general. But also fast throwaway tests. This is something I use XVR a lot. And you can use it also to learn OpenGL, as OpenGL is mostly exposed through our scripting language. So you can just use it like this. And as you will see later, this is how it is used in some cases. And it's not limited to this. Now, the good news for Blender heads are that recent developments, mostly fostered by me, are that we have some new Blender scripts that can import and export models directly into our native format. And now you can use Python 2 as a scripting language aside our custom JavaScript-like scripting language. And this, I think, can be interesting for many of Blender users which can be maybe accustomed to use Python, but don't want to learn other kind of languages. And Python is more powerful too. I admit it without problems. It was designed with different objectives in mind. And XVR is being also a way to introduce Blender in some university courses, as XVR is quite well known in the academic context, especially in those faculties which are doing research in virtual environments and the like. And so they are starting to use XVR in introductory courses about virtual environments. And of course, they looked for some free modeler. And so Blender is being introduced in these courses, and I think this is a really good thing. But you have to be sincere, just don't shoot the messenger, because there are also some bad news for Blender heads. Mostly, this is not open source. You don't have to convince me about open source. The point is that I can't convince my bosses about releasing this open source. But anyway, it's free for non-commercial purposes, and it will stay free. And developers are quite receptive, especially if a feature is requested by a broad user base. So I hope that it not being open source is not too much a hurdle. But if you want to know more about licensing, please contact, I will give you some contacts at the end. And maybe if a lot of people start to ask, this can also change, I don't know. I hope so. And the other point is that it's not natively multi-platform. This started as an in-house tool, and unfortunately most of our development happens under Windows. But anyway, there are some emulation workings for 86 Macs and Linux stations. They are somehow experimental, but also here, if there is enough interest, I think that portings are quite possible. We are using OpenGL after all, and so there are just some multimedia libraries which are Windows specific, but they could be disabled or, replaced by other kind of libraries. It's just a work that requires some time, development time, which is right now not being justified, but this is also something that can change if there is enough interest. So why developing an in-house solution? First of all, the problem was technology integration. XVR is not just real-time graphics. It's also about haptic interaction, network communication, and physics engine, and recently also positional sound, and also many other things, in a unified software framework, so that really complex settings can be set up quite easily and quickly. There is a fast development cycle because it's true that it is a compiled language, but compilation is extremely fast also for huge projects. And so you can just try out things and see how they come out at the end and change it. And it's really, really fast, much faster than a C application, Applications are organized around 6 basic callbacks, and there are 2 threads, one for graphics and one for custom calculations. You can put physics there or other things. So, more in detail, graphics provide a scene graph manager, vertex and pixel shaders recently, and also low-level OpenGL wrapping. But you can use it also without knowing anything about OpenGL, because the most frequent operations are wrapped, so that you can load a model and you obtain an object and you can rotate it and translate it with methods without knowing anything about OpenGL. But if you want to achieve some complex OpenGL effect, you can use them together, or you can use only OpenGL as you wish. There are also some basic UI functions to create menus and buttons. Sound management supports many formats and positional sound. Physics, there is collision detection, integrated tokamak engine, and there are some ODEM physics wrappings. And this is something which is changing quickly. So we could also integrate bullet. This was talked about recently. This could be also something which could be done after a user request, upon user request. And what makes XVR quite unique is a support for advanced devices for virtual reality, which are such as trackers and stereo projection, HMDs, all sort of haptic interfaces, and also cave-like renderings. I'll say more about that later. And there is also, sorry, disaster. Okay. No, this is not my mouse. Okay, so there is a simple network data management layer, but which allows to create network-aware programs. So the basic scene graph is similar to Blender's. This allows quite, easy mapping of the two. There is also a built-in profiler. There is also the possibility to extend the program by external DLLs. This is very used because we know we can't support everything natively, and so there is this possibility to just use an external DLL. And here's an example with real-time crowd rendering. A recent development is supports procedural modeling, so you can create procedurally just simple geometrical pieces and then join them together to obtain complex geometries with texture coordinates. And another interesting possibility is this external program, which is the XVR network renderer, so that if you have an XVR application on one computer, you can just install this network renderer, which is a layer upon the OpenGL drivers, which sends the OpenGL commands upon the network, and so that you can render huge images for really complex settings like that one, where you have more than one projector and really high resolution. You can just assign one computer to one projector and just render that part. You can also shift and rotate OpenGL point of view so that you can gain tracker support. And a mono OpenGL program can be adapted to become stereoscopic and to be visualized in a cave-like environment such as this one. So the original XVR application was not cave-aware, but it can become by means of the network renderer. Just a brief showcase of past XVR projects. These have been done without Blender, mostly because it was before I arrived, before I joined the labs. And so there are many 3D projects on the web, mainly about cultural heritage, reconstruction, about I mean, cultural heritage settings, and controlling sets of VR devices. As I was saying before, we have this motion-based simulator for warehouse vehicles, which is being used to train warehouse personnel. I've been working personally on this. And there are some neat industrial design applications so that you can fiddle with prototypes with a glove and stereoscopic view in order to see what the model would look like, changing some parameters, and then you can also explode the model and see the single pieces. This was one of the most complex projects that my lab has worked on. Okay, so there are also some strange things such as real-time medical imaging. So this is just a cube, but by means of pixel shaders, you can see a ray-traced volume rendering inside. The colors are strange because it was an anaglyph rendering. Oh, sorry. So that you could see it with the red and green glasses. And so also other applications such as this augmented reality, so that you can you can instruct a maintenance guy remotely and show him what he has to do to fix some misworking machine. So let's come to using Blender with XVR. First of all, why we were interested in supporting Blender. Of course, because it's a lightweight modeler. And we need frequently to edit on the fly some model on machines which are not under our strict control, so you cannot install some huge program such as 3D Studio just to do some quick on-the-fly editing, while Blender is, as you know, really non-intrusive. Blender is also interesting as a hub to import from various formats. And as I said before, it has been a frequent request from academic partners which look for a model that their students can install freely and without spending much. So Blender as a modeler, I wrote the exporter to export natively to the AM format. It supports animated meshes, hierarchical models, and hierarchical animated models, texturing. And you can also import from the AM format, which is a vital feature, as I said before, for on-the-fly editing on remote machines. This is a stupid, simple application, the first one that I did using Blender. So you can see the exporter up there. And it was an application about Galileo's Sidereus Nuncius. And it wanted to show how to display a text in a virtual environment. And the interesting point is that apart from exporting those simple models, I use Blender also to generate some of the code for the handling of the scene, some of the XVR code, for example, to load the positions of the various pages, because of course they are not really models, because they have to interact quite complexly, in a quite complex way with the interface. So the second part was using Python with XVR. There is this PyXVR extension which allows to embed the Python script inside XVR. This creates a dual script environment so that the two scripting engines can cooperate and you can get the best of the two worlds. So you can call Python functions from XVR and call XVR functions from Python. Not only callbacks, but also user-defined functions. And there is also automatic type conversion for basic types, so it's really easy to use these two languages together. And it's also fully debuggable using Python debuggers. The advantages are that you can modify and extend an application at runtime, something that was not possible with the previous scripting language. And you can exploit the huge Python standard library. For example, to obtain some more flexible multi-threading apart the two original threads. You can still use S3D, which is our custom scripting language, for libraries and all the already available code. Open issues are security. There are some problems with web applications if you allow the execution of unrestricted Python code, but we are working on restricted Python execution modes. And Python core is somewhat large to download alongside the rest, but this is something which can be reduced also. And right now, native S3D is faster, but this is because, as I said before, it has a more limited name resolution. It has more limited name resolutions facilities. So possible future directions of this cooperation is to use Blender as a high-level scene editor, exporting camera lights and shaders. And this is something quite simple. I'm working on this, and I guess it will be ready quite soon. But what I'm more interested into is to use Blender to generate code. For example, to specify the behavior of objects when something happens, so to specify triggers. And another nice thing would be to use Blender as to preview procedural modeling. Procedural modeling, as I've shown before. Another possibility would be to exploit the game engine and maybe perform some sort of automatic conversion from game engine code to XVR code. So let me thank all my colleagues for XVR, in particular Marcello Carrozzino for developing the AIM format and for documenting it, and Emanuele Ruffaldi for writing PyXVR. And of course, Blender developers and community. Here are some XVR resources, and if you have some questions about XVR and the like, I'll be here around for all the 3 days of the conference. So if you approach me and ask me every kind of things, I'll be happy to answer. And that's all. Thank you.